Hey, so this is a short video where I'm going to be making a demonstration of a new video, um, analog video effect unit that's available in underscores.shop. So we're talking about the 2.1 colorizer, which is a effect unit based on a design published by Rob Scharfer. And it's kind of a extension of another circuit I've adapted by Rob called the two comparator effect, which you can find the demo and info about also on this channel. So yeah, you can see the circuit board here, and this is available in underscores.shop right now. You can buy it as a bare PCB where you source and populate the parts yourself, or you can get a kit which has all the components you need and the PCB, and you assemble this yourself, or you can buy it assembled and tested by me. So for this demonstration today, I'm actually going to be showing you the circuit in this format, which is enclosed in a PCB sandwich style enclosure for the circuit. This is a new option which I'm going to be offering in the shop soon to add an enclosure to your circuit. So that just makes it a little easier to see because it has all the bits labeled on the front panel, and you don't have to see all of the components. So yeah, we're going to be using that version of the circuit for the demo today. So I'll switch over to the table camera, and here you can see a Recurboy, which is a Raspberry Pi based digital video synthesizer, also available in underscores.shop, and also in its new PCB sandwich enclosure. This is going to be the video source that's going to be passed through the colorizer effect, and we'll see the effect that the colorizer does on the default signal coming out of the Recurboy. So to get started here, we just need to take the RCA video signal that's coming out of the Recurboy circuit and plug that into the video in on the 2.1 colorizer. And then we take our video output. In this case, I'm just using one of these cheap USB capture cards to capture the output onto my computer. So I plug that in here and I turn on the source. You can see that's the default screen coming off of the Recurboy now. And yeah, I guess just to start us off, I'll just play a clip on the Recurboy, and this video is now being passed through the colorizer effect. Even though it's not powered, there's a bypass option, so you can always send the video straight through if it's in a chain of things. But let's take a look at some of the controls that are here on the 2.1 colorizer. So you'll notice, and this is actually the same as the two comparator effect, which I mentioned is kind of extended from this. We have two level controls, and these control the comparators, which decide which portions of the video are going to be colored and black. And then below them, we have this little triangle, three potentiometers and one switch per color stage, and this sets the color of that stage. So then we also have a switch selecting between ntsc and PAL format, and another switch here that's turning on or off alternating lines. Now we'll talk a little bit more about the alternating lines thing later in this video, but the default is to have it off. And just a note for the video format, this circuit is designed to work with ntsc primarily, and if you have the option, you should use it with ntsc video because the effects are a lot more interesting. This is due to the way that it generates color is kind of a bit hacky, and ntsc is more forgiving of this hack. PAL video introduced some color correcting into the format. That's what the PAL stands for, phase alternating lines, which is used to reduce the instability of a PAL of an ntsc video. But this also reduces what we can do with this effect. So I will show it in both PAL and ntsc so you can see the difference. But yeah, it's definitely more interesting in ntsc. On that note, because it's a bit hacky, the effects will be best if the analog signal is outputted to a CRT TV. As we'll see in this demo, it works just fine, just straight into a digital capture card. But yeah, especially on the more glitchier sides of what you can do with it, you'll see more of this if you plug it into a CRT TV. I'm going to power the circuit, and I'll give you an example of what it looks like. So first thing to do once it's powered is switch the bypass switch to the left, and that puts the signal through the circuit. Basically, when both comparators are all the way counterclockwise, the effect is completely black. And then if you bring the second one back around, we get a combination of that level's color, which right now is like a purple, and black. And then when you go all the way back to counterclockwise, then it's just all color. So that comparator switches between that color and black. And then the second comparator switches between its own color and the second one. So you can see here, we can have a combination of all of the first color, which is all blue, all of the second color, which is all pink, and black. So that's the 2.1 colors described in the name, where the black is the 0.1. And then of course we can have a combination of these. So that's what we're seeing here. And each of these colors can be changed, and that's what these like this part of the circuit is for. So it's not really any easy way to describe what the colors do. The best thing to do is just to try out the combinations and see for yourself. So I'll make it mainly this stage so we can see the kind of colors that it will go through as I turn the knobs. Yeah, what these knobs are controlling is the generation of the color burst, which is what sets the color on a composite video signal. And then this switch basically inverts the color burst signal, so that gives you another range of colors with it in that state. So yeah, it's basically just a bit of mucking around to see what this does. And then also we can do the same thing, of course, with our other color channel. And then finally, this potentiometer in the middle, this offsets the color of both channels together. So we can see that if we go all the way to the other way. There you can see it a bit. So it's mainly just at the clockwise end of the potentiometer. But see here, the green and yellow, we turn this slightly, we can kind of rotate through that hue. More yellow, more blue then into green, like that. So that's kind of an example of the color both. But yeah, it does only work when it's in certain states. That's just adjusting the length of the color burst portion of the signal, which was something which I added just to get that a little bit of that effect in there, which is quite nice. Then there's a few extra things you can do with it if you're prepared to kind of break the signal a bit. So one way you can introduce a bit more glitch to the circuit is by switching on this alternating lines switch. So I pull that down. Now we'll see how now the video is kind of switching in and out. The colors are scrolling a bit, and there's some rainbowy sort of effects. So this is what that alternating lines can do to the signal, taking it to some pretty interesting places. Sometimes it the encoder can't even recognize it as color at all, and it just starts to give you a whole bunch of gray lines and patterns. And then if you want to take that even further with the glitching effect, you can actually switch the format to the wrong format. So now we're taking the ntsc signal in, but if I switch it so that it's using the power crystal, then we'll see what happens to the colors. Now we've basically lost color because the timing doesn't match up. But what you get instead is also quite interesting. It's kind of a lot of scrolling bars and lines of different colors that the capture card automatically detects the format. So maybe it's switched it over. I'm not too sure, but yeah. Anyway, if you're not using the capture card, say using an old TV or something, you'll get some interesting effects from switching the format as well. Okay, so now the Recur Boy is outputting composite video in the PAL format, and we have the colorizer set to the PAL clock. So let's see what the difference is with the colors that we can generate. I won't be able to enumerate all the colors possible, but just to start with, you can see that quite a lot of the pinks and purples, deep reds that we could get before, we just can't really access those colors in PAL. It seems to be mainly limited to shades of white, yellow, blue, a little bit of green, which is still interesting and fun to play with, but unfortunately, yeah, the way the color is being generated is getting lost a bit in the color correction that the PAL format encodes. We can try switching the alternating lines on. Oh, actually, that was with lines on. Okay, so this is with lines off. Yeah, not too much difference there. Originally, I thought that the alternating lines might have helped us to get around the PAL color correction, which is how we discovered that makes some nice glitch effects. But yeah, I mean, I quite like these shades of yellow and green and muddy brown. Like, these are colors that, if you're just using a traditional RGB colorizer, you just can't access some of these. So yeah, still worthwhile. And still possible to glitch out the signal a bit. Let's try putting the wrong crystal on now, pal. Okay, so here we are with a slightly older version of this colorizer circuit, and we have it outside of the enclosure, so we can see all of the components. Now it should still be working pretty much the same as before. I switched it back to ntsc mode as well, although what I'm about to show you will work in both. So one thing that I discovered, basically these two ICs here, they're the ones which are driving the color burst generation, which makes the color. And I tried a few different slight variations on the ICs that are in the kit to see if they would behave differently, give us more or less colors, and so on. And the ones I landed on generated the best colors, and when it was working stable, worked the best. However, there was a few other ones I found that, although didn't behave correctly, definitely behaved incorrectly in an interesting way. So I want to show you an example of that and how we can switch that out to get some different kinds of glitchy effects from this circuit as well. So here's one of the ICs that I found that didn't make the cut but is worth playing with. It's a 74HC221E that's compared to the 74LS 123N that's currently in here. So what I'm going to do is switch out this IC on this channel, so channel 2, for the different IC, and I'll show you what that looks like. So first thing to do always is unpower the circuit if you're going to be unplugging things. I'll switch it back into bypass mode so we still see the video coming through, and then just with some tweezers I like to just get it underneath the IC, and it pops out completely there, and take that and put it to one side. And this IC has already had its legs bent in slightly so it will fit into the IC socket, so just put that on top and place it in, and now we can power the circuit again and switch it back into effect mode. So you'll see first of all that this channel, the first channel, is still the same. It's unaffected by the change. The only thing affected by the change is channel 2. So what you can see here is that it's still making some colors, but it's just not quite fast enough to keep up with the speed that's needed to generate correct color. So we get quite a lot more sort of these cross-hatching patterns and some kind of distortion-y effects that come into the color channel, which I think makes for quite a cool effect. So combine that with the alternating lines to see whether we get different. If you wanted this effect on both channels, you could switch out both of these ICs, but yeah, I quite like having a combination of one correct and one incorrect to just make some more variety in my patches. There was some other ICs that I also found to give some interesting results. So I might write a little document on the GitHub page so that you can find out for yourself what alternatives to explore if you're interested in going down this route. But yeah, that's really quite an in-depth look into the 2.1 colorizer circuit. I hope that you enjoyed the demo and might feel inspired to make one for yourself or to pick one up from underscores.shop. Thanks for watching, and I'll see you next time.